All right. So, while you're all looking for your perfect square list, run through these real quick. A plus 4, A plus 6. Chapter 1. W. A minus. And we did all of those together. Okay. Plus 6, 9, 32. Oh, factors 32. Okay. What's that? 8, 4, no, 16, 2. B minus.
Which chapter did we write that down in? It's lesson 1, 4.
H.
I swore it was in chapter. That's what I thought it was too.
No.
I'm looking at the triangle. Mr. Sullivan, we did 3 and 14 in class also.
Cool.
Yeah, it's not included up there. I was just telling him.
There. Checky, checky. Assuming that I can read all of the fuzzy, pixelated letters and numbers correctly. Okay. Mm.
I did mine off of like tree thing because I went back to my notes. I thought that's what it said.
You missed the entire point of the last 2 days. There's different ways to factor depending on what you're given originally. Okay. Check, check, check yourself. Better than that, check me. Make sure I didn't do anything goofy. Doing it kind of fast. Trying to read pixelated fuzzy numbers. Remember, the order doesn't matter. X minus 8 times x minus 3 is the same as x minus 3 times x minus 8. Okay.
Wait, is it this one? The vector, what? No?
What about him?
I was wondering if that's it.
Yes, it is that page.
Oh, yeah, so I did do my homework. Good.
Good. Okay, now depends on your numeracy. I know some of us, we got the mental mojo, where if you just had this, I would believe you. Some of us, not so much. But regardless, remember next to every one of these, I had said, check it. So if all you have is this, then you've got more work to do. Because Next to every one of these, you should have had n squared plus 4n minus 7n minus 28. So you can check, check, and those two add up to -3. Check. So next to every one of these, you should have a distribution problem as well. Now, we did, between what I did and what you did and shared with your compatriots last time, we should have half of this done together anyway. So, now that we've done that, dun, 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 dun. Go! Okay, we got an extra day of practice on it. We've got 2 days with this now. Show me. Remember when it says check, you need to show the distribution after factoring it to show that you're actually right. We're still going. Okay. Here we go. Oh, you're gonna be that way, huh, Frank? Yep, you're gonna be that way. Okay. So in each case, I want what times what makes negative 51, but adds up to a negative 14. I want what times what makes 42, but adds together to make negative 13. First set, I look all the way around on my multiplication chart, or I'm guessing and checking with the calculator. What do you think? Okay, 3 times 17 does make negative, or does make 51, and then I have to decide which one's negative. Okay, how do I know it's got to be the 17 instead of the 3? Both make negative 51. Okay, I checked it, and I know I'm right. What?
So, if the 3 is negative, then it's just going to add up to 14 instead of negative 14.
Okay, I've got a negative 14 there. I want my negative number to be the bigger one, so it actually comes to a negative number when I add them. Over here, what do you think? They both had to be negative because that's the only way I'll multiply to a positive, but add to a negative. So those are my answers. This is x plus 3, x minus 17. This is x minus 6, x minus 7. Now those are the actual answers. You also have to do the check with them to show that, yeah, you know what you're doing. In this one, I get x squared minus 17x, x squared minus 7x. I'm trying to keep all my colors in line here, that's why I'm doing both at the same time. Plus 3x minus 51 minus 6x plus 42. And I just need to check, well, I got my x squared and I got my negative 51. I just need to check if this actually adds up to negative 14, and it does. I got my x squared, I got my 42. I just need to check if this makes negative 13, and it does. Okay, so the check doesn't have to be too crazy. Just quick distribution, make sure it actually works. So, I'm going to say, do you have the right numbers and the right signs? Do you have the right numbers and the right signs? Did you show your checks? There's your 5. The right numbers, the right signs. The right numbers, the right signs. You checked them. Okay. Now, everyone has that multiplication chart, right? I had mentioned the perfect squares from first semester, because we used the perfect squares when we were doing simplifying radicals. You know what? That final ain't too far off. What if I threw that in front of you right now and said simplify it? Who can do it? Because we've done that about 50 times. Show me what you got. Show me what you remember from chapter, what was that? Chapter 1, section 4 or 5?
8 over 6.
Hmm?
8 over 6.
No.
What?
It's not a perfect square.
Wow, apparently I have to write out a simplify.
Isn't it like
Great.
somewhere in between?
Don't you give me decimals. I said simplify. See, decimals is just what the calculator is going to tell you. I can simplify this the same way that I can simplify fractions. Do you remember how? There were 2 ways to do this. Option 1, very related to the factoring that we were just doing. What do you think?
4 outside and 3 on the inside.
4 root of 3 is correct. Option 1, the way that a lot of us defaulted to, was very similar to the factoring we just did. You did a factor tree on it. What times what makes 48, Shane?
I hate myself.
Okay, yes, 6 times 8 does make this, but I have to keep going. Okay, so I can break it up like this and rewrite. This is 2 by 2 by 2 by 2 by 3. Do you remember that trick? This was, there's a level 2 guard standing in front of the doorway and he says, bring it. It takes 2 of those factors to bum rush the guard, because 2 times 2 is 4. The square root of 4 is 2. That's why when 2 rush the guard, 1 gets out. When 2 rush the guard, 1 gets out. And that's why there's 4 on the outside, 3 on the inside. We call it 4 root of 3. That was one way we did it. The other way involved these perfect squares. See, if I'm really good with my numbers, I might be able to just rewrite that using its biggest perfect square. So I'll go to my perfect square list and say, all right, Is 48 divisible by, find the biggest perfect square below 30 or below 48. And I say, does 48 divisible by 36? No. Is 48 divisible by 25? No. Is it divisible by 16? Yeah. So I can rewrite it as 16 times 3. That makes 48. And then the square root of 16 just is 4. So these were our two methods. I'm bringing that up because y'all got to know your perfect squares. Do we know if I have n and n squared, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, those you should know as just multiplication facts. What's 1 squared? Meaning 1 times 1. 1. What's 2 squared? 4. 3 squared? 4 squared? 16. Don't jump the gun. 25. 36. Yup. Okay, and then after that, you should also know, I bang that drum with my kids all the way into Algebra 2 and Pre-Calc. I tell them, hey, you remember when you were first learning to factor quadratics back in algebra? The stuff that you were just doing? I say, do you remember how, especially for my kids who were up in Pre-Calc, I say, do you remember that when it came time to factor those quadratics, maybe you felt like, well, what's the big deal? This is easy. And you saw some of your classmates poking buttons on a calculator a lot. Okay? Think back to the last couple of days. How many times have you had to poke buttons on a calculator a lot to double check things? If you don't know your multiplication facts, well, factoring can be a pain. Just like when we get further in math, if you don't know your squares, cubes, fourths of different numbers, it's going to make stuff with exponents really difficult. I recommend all of my students know all their squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as they can memorize. I just expect kids in Algebra 2 and beyond, they should know off the top of their head, what is 7 to the third? That's not knowing it off the top of your head, that's figuring it out. Should be 343. Number fact, just like I should know what's 6 times 8? 48. I should just know what's 16 squared without looking at your list. Chloe.
160 something. I don't know.
256. Okay? So do you have your perfect square list? If not, on that multiplication chart, 1, 2, 3, 4, 19, 20. 1, 2, 3, 19, 20. When you look at your multiplication chart, well, 1 times 1 is 1 squared. 15 times 15 is 15 squared. So write down the diagonal here. Those are your perfect squares. Okay, see how they're all in bold on your sheet?
It's highlighted on the.
Yes. So you don't need the perfect square list anymore if you just got that chart, because all of those bold or grayed in boxes, those highlighted numbers down the diagonal, those are your perfect squares. Now here's why you need to know those perfect squares. Y'all got, where is it? Not you, you go away, you. down in this space right here. Okay, y'all, 4-7 in your packet, right after that sheet we just did. I did skip 4-6. 4-6 is not something we're going to do in this class.
You mean 4-7?
No, we are skipping 4-6. That's why it goes straight to 4-7 in your packet. This little area over here, I would like you to multiply for me. Let's see those distribution skills. 9x minus 8 times 9x minus 8. Let's see your distribution skills, or your box method, or your FOIL, whatever your jam was. Disturber.
And it's your word too.
I always think of it like that because I grew up on Bert and Ernie. Ernie always said, "Sure, Bert. Disturber." Draw your little rainbow arrows if you need to. This is important because this is going to show you what today's all about. I'll tell you what, after that, I want you to do 9x minus 8 times 9x plus 8. I want you to do those because they're kind of important for what we're doing today. In fact, if you have your multiplication chart, today is kind of a I don't have to think day. I just look it up. Because there's tricks. There's little shenanigans that we can use. Answer! That was the drum roll before your big debut. Well, come on, man. I live with 2 domestic terrorists. If I'm awake, you can be awake. Children. Okay. What is 9x times 9x?
81x squared.
81x squared. Good. What is 9x times negative 8? X. And what is 9x times positive 8? Positive 72x. There's a difference between these two, and they are making the 2 special forms that today's all about. Okay, what about negative 8 times 9x? Negative 72x. It's the same thing again. Negative 8 times 9x, negative 72x. Negative 8 times negative 8. Positive 64. What is negative 8 times positive 8? Negative 64. Can I combine any like terms in the first one?
72x.
Okay, these are both x to the first, so they can go together. That's 81x squared. What is negative 72 minus another 72?
Negative 144.
Ooh, fancy. Plus 64. Can I combine anything over here?
Yes, positive 72 and negative 72.
What happens when I combine them?
Nothing. You cancel it out or put a 1.
No, not a 1. What's 72 waffles minus 72 waffles? This is subtracting, not multiplying or dividing. 0. 72 things minus 72 things is 0. Gone. Done. Bye. That's when I was dividing. This is subtracting. When I add and subtract, I can go to 0. When I multiply or divide, I can go to 1. Okay, because they are literally the additive identity and multiplicative identity. They have their own special feature. Those are the crown jewels on top of the addition and mathematic and multiplication pyramids. Like, squeeze. Y'all, what if I told you you can factor this? The factoring that we just did. This looks pretty big and ugly, right?
Yes, just like me.
Ow, dude. Ow. I want you to see something special about them, though. What do these two things have in common? They both have 81 and 64. Yo, look at the original problems. What's 9 squared? 81. What's 8 squared?
64.
Wasn't this something times itself? So squared. Something times almost itself. The difference between them was whether I had a middle term or not.
Wait, so what you're saying is basically we can just combine the two,
I'm saying there's a special form to these. And that special form is that if I ever have a minus b squared, meaning something times itself, or a plus b, I should say, it's always going to be of the form that thing squared, 2 of that thing times that thing. It's always going to end up the same. If I have a minus b times a plus b, these have a special name too. They're called conjugates. You hear about that term in English? Maybe you've been in a French or Spanish class. Conjugating verbs. Okay. To conjugate means to go with. A conjugate is a thing that goes with. They're paired. They go together because when I do, I get rid of my middle term. These are special types of factoring where I don't have to actually factor it. I just look up my perfect squares. What I'm going to do with these is I'm going to start with this. And I'm going to ask the question, are A and C both perfect squares? Yeah, they are. Those are perfect square numbers. Do I have a middle term?
Yes.
Yeah, I do. So that means it's going to be of the form something squared, something times itself. I take the square root of this guy, Good thing I got my perfect square chart. 9, and the square root of x squared is x. I take the square root of this guy, and I keep the sign. Isn't that what I started with? 9x minus 8 times 9x minus 8? 2 of them. I just factored it. Just by looking up perfect squares. Same thing here. Are A and C perfect squares? Do I have a middle term? See how there's no something x in the middle? That means it's going to be a plus minus pair. Conjugates. Square root of this guy. 9x. Square root of that guy. 8. Done. That's it. These are special forms of quadratics, and they got their own special way to do stuff. So do you have your chart ready to roll, because it's going to do all the work for you? Someone hit the child for me. All right. So come on down here. Factor the that. Well, are A and C perfect squares? See how they're, what number is in front of this? Okay. 1 is a perfect square, 36 is a perfect square. So that means this is one of my special forms. Do I have a middle term? No. So that means at the end of this, it's going to turn into a plus minus pair. They got a lot of stuff to show that. They got a lot of stuff to show that, but we'll see at the end, oh wait, it's just this trick. So stage 1, they say do the square root of the first term. That's just y. Remember we always cut those variables in half to bring them out of radical land? Square root of 36 is 6. Substitute them in the, this is called difference of squares. So I'm going to turn this into y plus 6, y minus 6. I take the square root of those two things and I get a plus minus pair if there's no middle term. If there's no middle term, plus minus. If there is a middle term, plus plus or minus minus, keep the sign. Now it's just a check. We said that it was plus 6 minus 6. Well, Disturbert. Take y times y. Take y times negative 6. But why?
Why?
6 times y. And 6 times negative 6. Negative 36. What happens in the middle when I combine negative 6y and y? Or 6y? Poof! Gone! Bye-bye! Turns into just y squared minus 36. Checks out. Okay, so these have a special format. I don't have to know the whole this plus this equals that. This times this equals that. I don't have to do that whole stage anymore. I just look up my perfect squares. So,
Never mind.
okay. Which y'all gotta really step up there, because I think this is the only class that has ever not gotten brownies off me in 14 years. Step up. Oh, I'm making plenty of mistakes. I screw up every day. I'm a human being. Okay? All right. This one's a little bit bigger and uglier. But what's the square root of 25? 5. What's the square root of x squared?
7.
No.
X squared X. Sorry.
Regular x.
My bad.
Boo. Now what's the square root of 49?
7.
Okay. That's it. This is of the form a squared minus b squared. It's going to turn into the form a plus b, a minus b. If I see two perfect squares and there's no middle term, then I can factor it without really doing any math by just square root of both plus minus pairs. So since the square root of the first guy is 5x, then it's 5x on both. The square root of the second guy is 7. 7 on both. The only difference is plus minus. That's it. Special factors. Okay? Think of this like, I mean, it's a shortcut. It's a cheat code. It's how many times have you been playing a game and then you come to find out, oh wait, this one spot, if I just chuck a grenade over those barrels, I don't have to fight these guys for the next 5 minutes. Because those are full of explosives. Goes the whole level. I win. Okay? Cheat mode. So, check it. We just said 5x plus 7 times 5x minus 7 makes this. So prove it. What is 5x times 5x?
5x squared, 10x, or 25x squared.
We got there. What is 5x times negative 7? Yep, negative 35x. What's 7 times 5x? 35x. And 7 times negative 7? No. 7 times negative 7? Negative 49. Take a look at that row. Is there anything there I can combine? Negative 35x plus 35x. You owe me $35. You gave me $35. We good. So I'm left with only 25x squared minus 49, which is what I originally started with. Okay? So that's example 1. Bruh. Okay? So down there at the bottom, give it a whirl. You got 3 minutes. So I'm going to explode.
have to do this. We did this already as a class. So you should like copy all
I
this
already
stuff.
talked about
You
it.
don't have it all done.
Well, I was doing this one.
Of course, I figured it out. I didn't say that. I didn't say that.
These are all fairly quick, right? Nice and simple. If the square root of x squared is just x, well, x. If the square root of y squared is just y, well, y. And then square root of 25. Okay. Hey, you. Do what I tell you. But I want you to pay attention to the plus minus there. The plus minus is specifically because there's no middle term. Also, you notice that all of these so far have been minus. That's very important because if that's x squared plus 25, you literally just jumped ahead 3 classes just by switching that minus to a plus. Okay, this only works if it's a squared minus b squared. Because otherwise, I don't know if we're ready for Are we ready for imaginary numbers yet?
No.
Okay. The thing on the bottom of the thing? No. 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 There are such thing as imaginary numbers. We're not there yet. Okay. Now these 3a squared. Okay. I take a look at it and I say, is 3 a perfect square? No. 3 is not a perfect square. Is 192 a perfect square? No. But if I combine my skills, is there a greatest common factor between these two? Oh yeah, it all comes back together. Break up 192. 192 is who times what?
3 times 64.
See how this is just, well, 3 and 1, so just 3. See, there's a greatest common factor of 3. If I take the 3 out of there, and out of there, I'm left with a squared minus 64. That's why we spent so much time on that GCF stuff. Is the GCF stuff, greatest common factor, helps me to get to a bunch of different ways to factor things. Now, isn't that a perfect square? Little 1 in front of it. Square root of a squared is just a. Isn't that a perfect square? What's the square root of 64? 8. So I have this magical pair here of plus 8 minus 8. A plus 8, a minus 8. And I don't know why they don't have a blank there for you, but it is a. Don't leave your kid brother at Burger King.
Sorry, you're too late for that.
Okay? Here's what I mean. We took that 3 out so that we could see the special perfect square thing. You might have to babysit your little brother, but you also want to go out with that certain someone special. So you head over to Burger King and you say, just shut up, leave us alone. Just go over there. Okay? Go hang out in the ball pit. I don't care. And then, like 11:30 that night, you get home and you're like, oh, wait a second. Where's Ian? Okay, and it turns out you got a plus 8, a minus 8, but did you remember to pick your kid brother up at the end of the night? That 3 is not gone. You just shoved him off to the side. Okay? I would bet he thinks the same thing about you. So, now we got to check it. Stage 1. We said 3, a plus 8, a minus 8. We said that was our magical jam. So I'm going to start by, again, shove kid brother over here and just leave him there for a while. What's a times a? A squared. What's a times negative 8? Negative 8a. What's 8 times a? What's 8 times negative 8? Can I combine any of those? You owe me 8 apples, you gave me 8 apples. Poof, 0. We're good. So we now have a squared minus 64, but remember, our kid brother is still here. He was just hanging out with us the whole time, all creepy watching you from behind the ball pit. Okay? So now we have to pick our kid brother back up. We're going to distribute. What's 3 times a squared? What's 3 times a negative 64? Are you sure about that? Are you sure about that? Or are you just assuming because that's what we started with? Actually multiply it out and make sure, because if we're not at 192, then we screwed up. Okay. All right. Just, I gotta check. Don't assume. Do it for real. And I get all the way back to where I started at. Okay? So sometimes it's not just the difference of squares thing. Sometimes you have to greatest common factor and then do the difference of squares thing. Okay? So here we go. These right now, yes, I know, 36 and 4, 169 and 49. Yes, those are all perfect squares. Can you take out a greatest common factor first? They showed you on 4. They have a 4 in common. Take the 4 out, tell me what's left. then do the special thing to it.
4 times 9.
No, no, take the 4 out first. There's a difference between I can factor a thing versus I can completely factor a thing. I'm just trying to give you the bare bones here before moving on to geometry. These square things, why would square numbers show up a lot in geometry? Dude! Because they're squares. Because you do Pythagorean theorem on triangles that involves squares. You're going to have these expressions in geometry. So we have to get this figured out now. No. They even told you, take a 4 out of both of them. What's 36 divided by 4? What's 4 divided by 4? X squared, 9x squared. Okay, now do the break it up thing that we were just doing with your special numbers. Yep.
Number 5 already broken up.
Yes.
4 out of that?
I don't even know. This is.
Okay. So just like up here, first thing we did was take out GCF. They're telling you what GCF is. So what's this divided by 4?
Don't know. What? Oh.
Go to 36. There you go. So this is 9x squared when I take the 4 out. Divide this one by 4.
Be 2 or
1.
1.
Now this is a greatest common factor thing. This is difference of squares because they're both perfect squares. So what's the square root of 9x squared? Just like up here, I did the square root of a squared. I did the square root of 64. What's the square root of this guy?
3.
And
X squared.
an x, right? Because x times x makes x squared. So 3x, 3x. What's the square root of 1? So that's it. That's the answer.
Okay.
You got to look up your perfect squares, and if you can take something out beforehand, you have to do that first.
Okay.
Did you do this with us? Because I wasn't here that class.
Yes, I did.
Alright.
Every class was giving you one. You gotta come up with a new plan.
Negatory.
Oh boy.
Because you didn't take care of this with the GCF. Remember, if I break this up into 2 and 2, break this up into 4 and 9, break that up into 2 and 2, that into 3 and 3, like we did before. What do they have in common?
They both have 2s.
That's why they took a 4 out.
And then you have to put that,
2 times 2, 4.
okay, now.
A pair of 2's in common, take a 4 out.
But you're missing the point.
So if I take a 4 out,
Plus and minus, it's a little bit.
cross that out, cross that out. This is now 4 times, there's a 3 and a 3 left, a 9x squared. Divided by 4, there's a 1 left. That's what this is.
Okay.
They told you, hey, your kid brother's in the way. Take your kid brother out. Okay, now that he's out of the way, just like we did up here, what's the square root of 9x squared?
So just 3x.
Uh-huh. So, those are going to be your plus minus pair. 3x, 3x. What's the square root of 1?
It doesn't work.
Yeah, it does. What times itself makes 1?
1.
There you go. 1, 1. And
Plus and an egg.
plus minus pair. Ta-da, done.
Oh, I completely underestimated that.
Okay, same thing here. See, they don't have anything in front. They're saying these two don't have a greatest common factor. But you can square root this and square root this with your chart to break it up.
Okay, thank you.
Mm-hmm. Okay, first one. They even told you. Maybe you're so starry-eyed over that special someone, you forgot what your little brother's name is. And they said, your little brother's name's 4, okay? Take the 4 out. Get the 4 out of there. So what happens when I divide this by 4 and divide this by 4?
9x squared.
Okay, I get a 9x squared and a 1. Now break those up the same way we were before. The square root of 9x squared is 3x. The square root of 1 is just 1. So that's what you're writing. 3x plus 1, 3x minus 1. Ta-da! Done. In the next guy. No. I'm very sure.
13.
What is the square root of 169? 13. Very sure. 14 squared is 196. Look at your chart. Oh, wait. Okay. And I had a whole pile of things over here too, and I think I threw them all away. Okay, the square root of 169 is 13. The square root of y squared is y. So 13y on both. Square root of 49 is 7. So plus 7 minus 7. There's my special pair. Okay. Down below this, boy, was that some foreshadowing. When would I ever use this in real life? Oh, hey, look, there's a square. Okay. So we got a big hunk piece of wood that looks like this, so we're going to cut a little chunk out of it. When would I ever do this?
Maybe it's makers.
Anyone ever done drywall?
Yep.
Okay.
A lot of times.
You got to cut the hole to go around your outlet, to go around your dryer vent, to go around your hood vent for your stove, for the plumbing, whatever it is. That's pretty applicable. So They say that it's S by S, meaning I don't know what S is, but it's going to be a big honking square where both the sides are the same. And I have to cut that little 4 by 4 out of it. So, what's the area of the big dog? The big S squared, right? S times S. What's the area of the little guy that I don't care about? 4 by 4 is 16. So I don't want to just say 4 squared, even though that is what it is, because I can tell you what 4 squared is. I'll write the number. Well, write an expression to model the area. You're going to get these a lot in geometry. I call them the donut problems. The donut problems are, here's the donut, find the shaded area. And the middle is not shaded. So what do? You take the whole donut minus the hole that was taken out. Right? The whole big thing minus the part you don't care about.
How do we get that?
By doing exactly that and subtracting. The area of the whole square minus the area of the little square I don't care about. The area for this thing is simply S squared minus 16. The big thing minus the little thing. But then they tell me to write it in factored form. So, I see a couple of perfect squares. I see no middle term. I know it's going to be a plus minus pair. I just have to find out what's the square root of this guy and the square root of that guy. What's the square root of S squared? Square root of 16.
4.
Ta-da, done. Okay?
Is that an S or a 5?
It's an S.
Okay.
That's why I normally don't use S's. When I do S's as variables, I try to make them a little curvy, and I try to make my 5s a little more pointy. But yeah, they look a little too much alike. I even know one kid who makes all of his 9s look like G's. Okay?
Yeah, you're looking right at him.
I'm not joking. 959 in Chinese. That is exactly how it looks on his paper. I'm not even joking. That's what his 9s look like. Okay, I know that. Took me a couple weeks to figure it out. But
At least he did it.
flip it over, what do you see? Get it?
So we can do this next class.
No!
I think.
Because you know what's next class?
I'm guessing a test.
A test!
No, thank you.